Okay, if I take a look at number 12. Miko, will you close that for me, please? Thank you. 12 said, I have negative 7 halves times x minus 5 halves plus 2x is equal to a negative 17 fifths. Cameron, is this the one you're talking about? Awesome. Okay. So I'm just going to rewrite this. Cameron, what common denominator or what common multiple do you have? Those two are that's asking the same thing. Do you have between these denominators? Excellent. So I'm going to show multiplying everything by 10 or 10 over 1, including that 2x. That's the biggest mistake I see people make, is that they forget. Danny, you're taking notes on all of this. So you can do it in your note spiral, you can do it in your homework where you're going to be starting your next homework as a guide for you, whatever you want to do. But it should be in the next, like the next thing. I know, but we're doing some of the problems. Is that like the next page in your homework? Flip the page back. Other way. Other way. Okay. I'm just making sure it's not randomly placed in there somewhere. Okay. So I'm going to multiply everything by 10 or 10 over 1, Cameron. Are you cool with that? Okay. So I'm going to divide out common factors. So I divided out common factor between the first two. I get 5 times negative 7x, which gives me a negative 35x. Minus, now if you did adding the opposite there, that's fine. Alright, so I'm going to have minus 5 times 5, which is 25, plus 20x is equal to, divide out here, that becomes a 2, and that's going to be a negative 34. So are you cool so far? Okay, so now I am going to do adding the opposite here, because I have like terms here that I can combine. So I'm going to move those like terms next to each other. And I'm going to add them. Well, negative 35 plus a positive 20 is a negative 15x plus a negative 25 is equal to a negative 34. Are you cool with that? Okay. From here, I'm just going to add 25 to each side. So I have negative 15x is equal to, well, this is the order in which I need to do the subtraction, because the greater absolute value is on the top. Everyone's looking at number 12 from the worksheet and paying attention to what we're doing. So 34 minus 25, well, that 3 becomes a 2. That's going to be a 9. And it's going to be a negative 9 because that 34 was negative. Are you cool with that? Awesome. So now I'm going to divide both sides by negative 15, and I end up with x is equal to, well, 9 and 15 have a common factor of 3. So that negative 9 becomes a negative 3, that negative 15 becomes a negative 5, all right, or a positive 3 and a positive 5, because we're eventually going to turn those into a positive, because a negative divided by negative is a positive. So 3, or x is equal to 3, a positive 3/5. And I hope that was our answer. Are you cool with that? Did you find your mistake? Sweet. What else from the worksheet can I do? Ada? 22. So 22 said I have a negative 5/4 times a plus 1/3 plus 4/3 is equal to 25/6. Now, Ada, on this one, because these two fractions are both constants, right? They both already have a common denominator. If you want to add them now, you can. If you didn't add them right now, that's fine, but you could. Eventually, we're going to. So I'm going to just go ahead and do that. I don't have to do any common denominator work for adding those, so I'm going to go ahead and add those. So that's going to be 5/3 is equal to 25/6. If you did not do that in this step, that's fine. You're going to do it after you clear your fractions. At some point, you're going to do that. Okay. So what common multiple did you use, Ada, for this? Excellent. So I'm going to multiply everything by 12, or 12 over 1. When I do that, my 4 divided out, the 12 becomes a 3. So this ends up being 5 times negative 3a, which is a negative 15a, plus Well, my 3 divides out, and that 12 becomes a 4, so that's plus 20, is equal to, well, the 6 divides out, and the 12 becomes a 2, and that's going to be 50. So as you guys are correcting yours, I do want you looking at what mistakes you made in your original problem, so you can make sure that you don't make that same mistake again. So I do want you making the corrections next to the original work, so you can compare them to what you did. All right, so Ada, are you cool so far? Okay, so now I'm going to add a negative 20 to both sides, and I get negative 15a is equal to 30. I'm going to divide both sides by negative 15, and I get a is equal to a negative 2, and I hope that was our answer. All right, how about the book? What can I do from page 262? Alex? 28. Let's take a look at 28. All right, 28 said, I have a negative 1.7w minus 4 is equal to 2.63. Is this the problem you're talking about? Awesome. All right, so I'm just going to rewrite it. I just don't want to touch my given. I am going to do adding the opposite here. It doesn't matter if you do it now or you do it later. All right, so Alex, what am I going to multiply every term by to clear my decimals? Excellent, because that last term is to the hundredths. Even though this is to the tenths, that's the smallest place value. So I'm going to multiply everything by 100, including, Alex, that negative 4. That's the biggest mistake that I see, is that people are forgetting to multiply the whole numbers as well. So I'm going to multiply that first one by 100. All right, so I end up with negative, well, I move it 2 places, so that's a negative 170w plus negative 400 is equal to 263. Are you cool with that? Awesome. I'm going to add 4 to each side. Or, I'm sorry, 400. I get negative 170w is equal to 663. Divide each side by a negative 170. All right, and when I do that division, I end up with 663 divided by 170, and I should end up with a negative 3.9. Are you cool with that? Okay. Okay, no big deal. Valentina. It's not 3.86. It is 3.9. 663 divided by 170 is 3.9. But if it was 3.886, blah, 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 we're going to round, as Sophia pointed out yesterday for us, because that was a good question, round to the smallest place value of any of our numbers. Okay? Matthew? 24. All right, and then we have to move on. All right, if I take a look at 24, Matthew, I think this is the one you're talking about, 10.7w plus 4 is equal to 47.87. Is this the one you're talking about? Awesome. All right, so Matthew, for us to clear decimals, what do I need to multiply all of our terms by? And what would that be? Excellent. So I'm going to multiply everything by 100 again. So that first one is going to be 1070w plus 400 is equal to 4,780. Are you cool with that? All right, so now I'm going to add a negative 400 to each side, or subtract 400. So I have 1070w is equal to 4,387. And then I'm going to divide each side by 1070. All right, so I have 4,387 divided by 1070, and I end up with my W is 4.1. On a test, you will have your calculators. On a quiz, you will have your calculators, okay? On your homework, I'd like you guys to use your brains. Are you cool with that, Matthew? Awesome. All right, put this away, get your notes out. If you still have more questions, I'm so happy to help you. So just come see me. If you need to see me at lunch, tell me you're coming. All right, that way I'll make sure that I stay. All right. All right, so what we're going to talk about today is we are going to be talking about, so today is the 29th. We are still in chapter 5.7. So 5.7 continued. All right, but what we're going to look at now is we're going to look at solving inequalities. So I'm adding this to what we're doing. All right, I do want you, so use clearing fractions and decimals when necessary, when appropriate. So in tonight's homework, if you have a story problem or if you have a skills-based problem that has decimals in it and it's an inequality, you're clearing decimals. If you have fractions, you're clearing fractions. I want you practicing that skill still. Okay. Okay. So when we are doing inequalities, all right, you have to, I'm just thinking for a second. When you are doing inequalities, your game plans must be parts equal to your whole. They have to be. Because when we do that, our parts, this is our actual the actual math. It's what we're doing. Our whole is either a maximum or a minimum. Do you need something from my desk? You know that works. Okay. Awesome. I appreciate you thinking of me. Thank you. All right. So you always have to do a maximum and a minimum or a minimum. All right, in your game plan. So if you're looking, you always look for rates. All right, so your parts of your actual math, the whole is your maximum or your minimum. All right, so let me show you a story problem. All right, go ahead and write this problem down, and we'll do this one together. We had one kind of like this in our homework that gave us kind of a preview of this. How do I know with how this is written that it's an inequality? What phrasing in there indicates that this is an inequality? Cullen?
What are the original prices?
Yeah, it doesn't say what is the original price. What are the original prices? What else does it say in there? In that sentence that goes with that. It says, what are the original prices that you can afford to buy? All right, so it's not what is the original price. What are the original prices that you can afford to buy? That indicates that's an inequality. So I want you to write that. I want you to write that question down. That whole question. So everyone's writing that sentence down. That question. All right, and let's walk through this together. All right, so here's our given. And I want to highlight that sentence a little bit again. So this phrase right here, what are the original prices they can afford to buy? Because of that, there's more than one price option. That indicates that we have an inequality. All right, so if I set this game plan up, do we have a minimum or maximum? This is what you should always start with, because then everything else is a part. Do we have a minimum or maximum that we are spending? Matthew, what's the maximum up there? What's the money you have to spend? What's the money in your pocket? Nope. What's the money in your pocket? How much money is in your pocket? Cameron? $20. This is how much you have to spend. That is the maximum you can spend. So your mom says to you, oh, but I have a gift card you could use too. That's not part of your whole. Those are your parts that go with everything else, right? So that gift card is part of our parts. So let's figure out what that means. All right, so the maximum cash to spend. All right, so our parts are what we are actually doing with our money. What am I buying? What am I buying? Ada? Right, so we have the original cost of the shirt. Is the shirt on sale? So don't I need to take off of that the discount amount? How many of you guys agree with that? All right, so I'm going to subtract off the discount amount. What else am I going to subtract off that cost? Sophia? Yeah, that's the gift card. I'm going to take that off the price because the cash register is going, this is the money you have in your pocket. That's the money you're going to hand them is the $20. That's the maximum you can spend. They're going to take the discount off the original price, then they're going to take the gift card off. How many of you guys are good with that? Okay. Can what we are spending be more than the $20 in our pocket, the maximum, or can what we are spending be less than? What does it have to be? If we have a maximum in our pocket, what can we be doing? Danny? It has to be less than, because what we are spending money on has to be less than that maximum. Can we spend that entire $20? Can we spend that entire maximum, Danny? Yeah, so then we become an equal to. So when our whole is a maximum, you notice that I wrote down maximum cash to spend. I just didn't write down cash to spend. Because once I recognize it's a maximum, you're like, oh, that's right, everything we do has to be less than that. That helps you figure out that inequality part. All right, so let's break this down. So, how do I figure out, let's say X is the original price of the shirt. How do I figure out my discount amount? How do I figure out my discount amount? Amanda? So mathematically, what does that mean? So 1/3 off. Mathematically, it's 1/3 of the cost of the shirt. So this is 1/3 of the original cost is our discount amount. How many of you guys agree with that? 1/3 of the original price is the discount amount. What does of mean when we have a fraction of? Addison? A multiplication. So there is our original price again. There's our X again. So here we have X minus 1/3 times X minus 5 is less than or equal to 20. Danny, do you have a question or are you answering something? Okay. Okay. How many of you guys are cool with this? Okay. Let's finish solving it. So all of you finish this. I do want you clearing fractions. It's not necessary to get it right, but I want you practicing it. So I want all of you clearing fractions here. What are you going to multiply by to clear fractions? AJ? No. What's my only denominator up there? 3. I mean, you could multiply by 60, but that's a lot. There's no other denominator. I don't care about this 20. Because this 20 and this 5, these are whole numbers. The only denominator I have is that 3. So I'm going to multiply everything by 3. Now, in the future, this might be one where you're like, clearing fraction doesn't really help me out here. So don't do clearing fractions in the future. Right? So you're going to kind of decide when it's a good idea and when it's not moving forward. All right, but in your homework tonight, if there's fractions, I want you using clearing fractions. So I have 3x minus 1x minus 15 is less than or equal to 60. Questions on that so far? All right, now let's finish. I'm going to do this as you're doing this. What is 75 divided by 2? Amanda? So it's money. So you need to tell me, remember, X is the amount, X is the amount of money, isn't it? So am I going to say $37.50? $37.50. So let's check that. 75 divided by 2. X is going to be equal to 37.5. Remember what your information is. If that was number of things, we could say 37.5, but then we'd have to make sense of whether we can have a half a thing. But since this is money, it's 37.5. Someone explain what that answer means. Explain what that answer means. Addison? No. Not quite. This is an inequality. You guys got to make sense of what the inequality means. So the original price of the shirt is, somebody finish that off, it's an inequality. If this was X equals 37.50, I totally agree with you. What does this mean? Valentina? Absolutely. The original price of the shirt is $37.50. That dollar sign has to go in front of your number, by the way, not after, or less. How else could I have said that? Matthew? Absolutely. We could say no more than $37.50. How else could I have written that? Ada? No, it can't be definite. So if you say can be, that's the same thing what Addison said. That means that the only number it can is be is 3750. This is an inequality. What else could I write, Molly? Absolutely, we could say at most. How about a maximum of? All of those are appropriate ways to say that. So in your story problems, when you have inequalities, you have to somehow indicate with your words that it is an inequality. You can't say it is $37.50 because that's just the maximum it can be, not all the possible ones. Does that make sense to you guys? You guys cool with that? Okay, you guys are good to go.